All right, so let's talk about this internal. Like I said, I'm going to scrap this question, or sorry, I'm going to scrap these two questions from the internal because y'all weren't ready. Okay, so with this internal, some things to keep in mind. You'll be given just an introduction to the assessment. I should actually change this. It's going to be over 2 because we're going to do, if you guys see your marking schedule, I have mark for task 1, task 2, task 3, and task 4, and the mark for your overall internal is going to be based off of your best 2. So if you have achieved, merit, I'm going to give you merit. If you have achieved, merit, you're going to get achieved. If you have merit, excellence, achieved, you're getting merit. So whatever top 2 grades that you have will be the final grade. So you need 2 of the same mark to get the same overall mark. So I'll give it over 2 sessions. I'll give you guys 2 questions. So that'll be on the Monday for next term. I'll mark them. I'll give you the feedback for the Tuesday. And then on the Friday, you will have your final 2 questions. If you get excellence on your first 2 questions, there's no other way to improve. So you don't have to sit the next 2 questions. You can just go with the merit, excellence. If you have merit, or merit excellence on your first 2 questions, I will give you a merit. And if you want to sit the next 2 questions, you can. What that means is only one of these 2 need to be at excellence to get excellence overall. Does that make sense? So it's up to you guys if you want to sit the second 2 questions when we get to that point. Cool. So this is just kind of an overview of the things that you're going to be doing. I will give you 2 parts. I'll give you part 1 and a description of each task, and then I'll give you part 2 with the description of each task on then the Friday. So that's what it's going to look like. So let's unpack these questions and understand the marking schedule. So this is the first one. So for the first task, we had 2 colorless solutions, potassium iodide and nitric acid. They are mixed together, and the solution changes from colorless to brown, and brown fumes are forming off of the solution as well. So I made a small error on the marking schedule, so I'll just point it out to you guys. I've tried to note it on there. This first statement about the observations is actually a merit requirement, so that's why I've drawn that arrow to state it is a merit. And the other thing is I want, instead of state correct observations, is link correct observations. So by linkage, I mean that whatever the observation that you are stating, you have identified what chemical is causing that observation. There's lots of different ways you guys are able to write it. I'm not too fussed how you write it, but I need to see some sort of identification that you know what's going on observation-wise. I will hold off on doing the observations till later because I want to show you the different ways you could show it to me and that I would count it as a linkage. So task number 1, we have the potassium iodide with the nitric acid. Just making some notes on things that I see and how to figure out what my products are. I'm just trying to find my resource sheet. I should have, oh, there it is. Okay. So here is, actually, do I have it underneath? Yeah, let me get a fresh one so that way you can treat it like it's on the actual assessment. So first thing I would do is I would break these guys apart into their individual components. So that's potassium and iodide as my first 2 reactants. And as my second 2 reactants, I have the hydrogen and the nitrate. When I look at the resource sheet, potassium isn't on there. So what that suggests to me is that potassium is just a spectator. I usually don't include anything that is spectators, just to help ease with the noise. Iodide, I see over here, and that's colorless, which makes sense. And then I have, so basically I've just decided that out of the first reactant, the potassium or the iodide is part of this reaction. Potassium I've eliminated. And then the second 2, I have the hydrogen and I have the nitrate. So hydrogen I have over here. This is a colorless and it's in solution. And then the next thing that I have is the nitrate, which is over here, and that's colorless. in solution as well. AQ is aqueous. So that's my first thing. At this point here, I don't know which of these two are going to be part of my reaction, so I need to look at the observations to help me figure that out. When I look at my observations, it states that we are going from colorless solutions, and the solution turns brown, and there's brown fumes. So I need to figure out what the brown liquid is, or the aqueous component, and the fumes, which is the gas. Are we good so far with that? All right. So I know that the iodide is already involved. So if I look for the iodide, the only thing that is also gotten that I element is the iodine. I can see that this is aqueous and it's a yellow-brown color. So it's in solution, yellow-brown color. So that helps me identify what this is. That is the I2. The next thing I need to identify is the brown fumes. So either we're talking something that's related to the hydrogen or something that's related to the nitrate. So with the hydrogen, I can see you can form hydrogen gas, but hydrogen gas is colorless. So that is not the answer. If I go down here, I see there's nitrogen dioxide. It is in the gas form as well, and this is brown. So that tells me that out of these two, this guy is the reactant. That is a spectator. Oops, sorry. I'm going to refocus that. Are we good with that so far? So with each one of the reactants, if they're an ionic compound, I need to split it up into the ions, and I got to figure out which of these two ions is involved in the reaction and which one is just the spectator. So my brown fumes, that is the NO2. Are we good with that so far? All right. Next thing I need to figure out is which one is the oxidation reaction and which one is the reduction reaction. So I'm going to start noting some things down as equations just to kind of help me identify which one is which. At this point, I'm not balancing them. I'm just kind of using them as a reference point. So I have I minus becoming I2, and I have NO3 minus becoming NO2. Now, I'm going to be nice, and I'm always going to give you one item that is not a polyatomic ion. So this one here is a polyatomic ion. This guy up here is not. It is monoatomic, so it has one ion in that element, or sorry, in that chemical. So I want you guys to use the monoatomic ions to help you figure out which one's oxidation and which one's reduction. Because with this guy here, you're only going to be able to figure it out if you use oxidation numbers. So I'll be nice and give you one that's easy to identify. In this case here, I see that this has become started as a negative ion, and it has now become a compound. So in order for it to become an ion to compound, it must be losing electrons. So if it's loss of electrons, remember, write Leo the line says GER, or you can write oil rig. Oxidation is loss, reduction is gain, whichever one you want to help you remember. So for my oxidation reaction, I'm going to copy this down. I start with I minus going to, oh, sorry, that's achieved. Let me put that back in red. I minus going to I2. And since I've identified this one as the oxidation, this must be the reduction. Make sure you have those charges on there because that's important for the chemistry language. Yes. No, so I am choosing the monoatomic ions out of these two. And when I look at this one here, I see that starting as a negative anion. And for it to go back to the element, it's going to have to lose some electrons. So it's going to lose that negative charge. So oxidation, loss of electrons, oxidation, gain of electrons, reduction. Cool. All right. So since I've assigned this one the oxidation reaction, this one has to be the reduction reaction. This one you can figure out that it's the reduction reaction, but it's going to require you using oxidation numbers to figure that out. And for the achieve, that isn't a requirement to do. So I need to teach you another way to find it. And that's why I'm setting up the questions to be quite easy. One easy, one hard. All right, cool. So other things that I'm going to note down, not a requirement in the assessment itself, but does kind of show that chemistry language. So let's say I'll put this at the excellence. So identifying that this is an oxidant and this is a reductant. Stating that you know that the reactant, the nitrate, and the iodide are both the reactants. So nitrate is the oxidant, iodide is the reductant. Remember, when we're using this terminology, we're thinking about what is it doing to the other half of the equation. Are we good so far? All right. So looking at the requirements here, identifying correctly that this reaction here is reduction, that reaction there is oxidation, that is the achieve requirement. The second thing I need you to do for achieved is I need you to just give me the definitions of what oxidation and reduction are. So for example, you state that this is a reduction reaction because it has gained electrons. I'm leaving a little space there to add the specifics later. The other thing you could write, so this is an or option. So either you write gained electrons or you write decrease in oxidation number. So long as you have one of those two statements down, I can give you an achieved. For this side, you would write that it has lost electrons, or you could write that it has increased in oxidation number. That's all I need for the achieved. Let me just zoom it out so you guys can see the whole thing. Should be writing on your scripts, please, so that way you know what you need to do to fix it. All right, we okay? So if you look at the assessment criteria, links oxidation or reduction to increase, decrease, or gain and loss of electrons. That should probably actually say and. Just telling me you know your vocabulary. Very good. Okay. Next thing, when we start looking at the merit level, is can you balance the equations? I'm looking if you can balance one half of those equations. So there's two half equations there. So long as you can do one of them, I'll mark it at a merit. So the easier of the two, in my opinion, is this guy over here, because that one doesn't have any waters or oxygens or hydrogens to worry about. So remembering the steps. Since the first thing I do is balance the active reagent, since this is 2, I need to balance this so it's also 2, and I can only add things as coefficients, so I'm adding the 2 to the front. Cool. Right, next step is I need to then add my electrons. I'm very mindful of which side needs to be added to the electrons. What I look at is the charge of the overall equation, and from the charge, I add electrons to the higher of the two sides so the numbers match. This is currently -2 because I have a -1 charge here and I have 2 of them. This is currently 0 because there's no charge on molecules. So to bring this down to -2, I'm adding 2 electrons to that side. So looking at our assessment, balancing one half of these half equations correctly, that is one of the requirements. The next thing I'm looking for is, do you have a justification to explain your oxidation or explain your reduction? And I want specifics. You can either talk about specifics in the number of electrons transferred or how the oxidation number has changed. I need it for both the oxidation and the reduction. So for example, on this guy over here, I can identify that it's lost 1 electron. Remember that there are 2 iodides here, so each one loses 1 electron. When you guys write the justification here, I want you to write it in terms of one atom. And then this one here, again, it's another or. So either you justify it with the change in electron number or you justify it with the change in oxidation number. In this case, it is increased by 1. We've gone from -1 to 0. Questions, concerns, comments so far? All right. This side over here, I will need to use oxidation numbers to figure out how things have changed. When I look at this guy, the overall charge for the nitrate is -1. I have 3 oxygens, so that's -6. So this must be +5 for me to get -6 overall. Do you guys see how I've gotten that, or do you need me to break it down? Break it down? Okay. Let me put it on the back. All right. NO3-. So if I was to break this down, you have nitrogen and you have 3 oxygen, and that together makes up the nitrate. If I want to substitute in my oxidation numbers based off of my oxidation rules, which I do give you on the assessment, I'm just trying to wait for that to focus. There we go. All right, so nothing in here on my list states my nitrogen. So my nitrogen becomes my unknown. Oxygen I see has an oxidation number of -2 in compounds, or in ionic compounds I should also add. So that's going to be -2. And I'm multiplying it by 3 because there's 3. Oh, come on, why is it not focusing today? There we go. I'm multiplying it by 3 because there's 3 oxygens there. I'm then setting it equal to the charge of that polyatomic ion, which is this rule over here. In polyatomic ions, the sum of the individual oxidation numbers equal the charge of the ion. So that's going to be -1. So x plus -6 equals -1. I add 6 to both sides, so that way the 6's cancel out. I get x equals +5. So that's where nitrogen's 5 is come from. Good? Okay. So then I have the nitrogen dioxide. In this case, I use similar rules. Oxygen is still -2 because it's in a compound. The overall charge is 0 though. So if I have -2 times 2, that's -4. In order for me to get to 0, I need +4. You good? Okay. So I have, in this case, gained 1 electron. The oxidation number has decreased by 1 from +5 to +4. And again, it's an or option. I just need the justification in one spot. We good? Okay, keep going. Okay. Next thing I'm going to do is I'm going to balance this second half equation. Now, actually, I should stop at this point. We're more or less at the merit level with what I've written so far. The only thing that's missing is the linkage to your observations. But I'm going to do that actually at the very end once we have the full equation, so I can show you guys a few options and how you link. So, balancing this half equation here, I check to see if the active component, which is our nitrogen, that's the one that's changing oxidation numbers, I check to see if that's balanced. It is, so I don't need to do anything. Next step is to check the oxygens. I see I have 3 on this side and 2 on this side, so I need to add another oxygen onto my left or my right-hand side of the equation. I can only do that by adding water. Now that I've added water on this side, I need to counteract the hydrogen I just added by adding hydrogen ions to the left. I'm going to do that by adding 2. And then my final step is going to be adding the electrons. The charge on this side is 0. The charge on this side is positive 1. So I need to bring this guy down to 0. And I do that by adding an electron. For the merit, I only need one of those half equations. So if you got the simpler of the two, I would be able to still mark you at merit. If you are aiming for excellence, which you should do, it's a pretty easy assessment, I need both. And in fact, you won't be able to get the excellence anyway without both of them because you need to combine the two equations for excellence. So my last step is to combine the two for excellence. I'm looking at the electron numbers, and the electron numbers need to match. This is 2, that is 1, so the bottom half gets multiplied by 2. So that goes as a 2, that becomes a 4, that becomes a 2, that becomes a 2, that becomes a 2. I then put everything together. My electrons should cancel out. The electron numbers should be on opposite sides of your equations. It's a really good way to idiot check yourself because one needs to be oxidation and the other one needs to be reduction. Electrons need to be lost somewhere and they need to be gained somewhere. We are not creating or destroying matter. This is not nuclear physics. Actually, I shouldn't even say that. You can't create or destroy matter. No. All the matter that exists in the universe has existed forever. Put it together. Make sure you have all your charges on there because I will not mark you as a correct equation if you forget your charges. That's my full equation. Questions, concerns, comments? Lucy?
Why did you need to get everything multiplied by 2?
So that way the electrons cancel out. Because right now this is 1 and that was 2. So if I multiply this bottom half by 2, I now have 2 electrons to cancel out these. Yeah.
It's just all cancel. How did you figure out that it's even
minus 1? So this side is 0 because both of these are molecules with no charge. This side has a a positive 2 because there's 2 hydrogen ions. This has a negative 1 because there's only 1 nitrate. So positive 1 plus negative 1 equals positive 1. And I want to bring this side down to 0. So I add an electron. But since these electron numbers didn't match, I'm then doing that multiplication. Cool? All right. Let's go to the last step. This is actually a merit requirement. So I need to have observations, and I want these observations linked to the chemical species that is causing that change. 2 options on how you do that. The first is that I would like you guys to write it here anyway. So if we go back to our task sheet, we can copy down this statement and we can make our annotations on what's what. So 2 colorless solutions are mixed together forming a brown solution, I2, and brown fumes. That is showing me, that is showing me linkage because now I'm actually stating the observation and I'm stating what is causing that observation, which is that guy here. There's a second way that I'm willing to accept it. Just kind of zoom out so you can see both. Okay. The other way that I'm willing to accept it is if you annotate the equation and you note what's brown and what's not. So that would be aqueous, that's aqueous, that's aqueous, That's aqueous. That's a gas. That's a liquid. So you go through and you state your states. You can state that all these guys here are colorless. That's colorless. That's brown. And that's brown. I will also accept that as observations that are linked. Because you stated, here's my equation. These are the states of all these compounds, or sorry, all these chemicals, and these are the colors for all these chemicals. So that's another way I would accept it. And if you guys want, you're welcome to write it both in case you're worried about making a mistake somewhere. So everything in red is what I need for achieved. Everything in red and blue is what I need for merit. Everything in red, blue, and green I need for excellence. What you'll notice in this assessment is that there's a big jump from achieved to merit, but there's a very small step from merit to excellence. I find a lot of times with this assessment, people either get excellence or they get achieved. All right, questions, concerns, or comments? All right, I am going to, because I don't want to talk for the whole session, I will point out the various bits of things you can do for work to help you practice. Actually, let me go through the marking schedule first. So links oxidation number, or oxidation with either electron transfer or oxidation number, links reduction with electron transfer or oxidation number. So when I say correct number, I'm talking about the specifics. So it lost 5 electrons, that sort of thing. For the excellence, balancing the full half equations, balancing the full equations. These are more or less one of the same thing because you won't be able to do the full equation unless you have the half equations correct. And I decided to actually remove this because looking at the clarifications, that's not actually a requirement, which is strange. So really, all you have to do extra as your excellence is that full equation. Okay, let me kind of give you your options for the remainder of this lesson. First option that you guys have is I'm happy if you want to spend this time looking at that second question I gave you and writing this one up and trying to do those corrections. You do have the marking schedule for it, so you can see how the points broke down. The other thing that I've done, let me pull it up on Google Classroom, and I also have the printout for it. To be on the chemistry and on the science pages. All right, so I have posted assessment style questions. There we go. It's a nice little Word document. I'll update those instructions. Okay, so there are side pages that you guys can do that'll be really helpful, but if you want to practice questions on the assessment template and get used to that, what I've done is I've taken those side pad questions and I've converted them into statements like you would get on the assessment. So it states what 2 things you are mixing together and what the observations are and also what the products would look like. Okay? So there are lots and lots of questions you guys can do as practice. I have this printed out. I can grab those spare copies. I have printed out lots of copies of the template, so feel free to grab a couple of these. I know people have been grabbing them, but I would suggest that you grab some more. I would suggest 3 as your kind of like minimum to grab because I printed 60 copies here, and I think I have a few more somewhere in my office or in my classroom. All right. Use the rest of the session to get some practice done.
Recorded. So that I got an achieve, and you want to know why?
If I had a pen around here, that'd be more pleasant for my book. Nope.
But I put positive 3 to 0. That's supposed to be positive 5, positive 4. And that's why I got an achieve, not a D. If I hadn't done that, I would have passed it. I mean, still. It was confusing, and then actually, yeah. Let's not do 5. Was the way out. No, I just found a lot more on that side.
Yeah, it's double-sided, so you basically have 6 practices.